January 2025, the phrase military-industrial complex tends to provoke immediate reactions. For decades, it has been used as a warning, a critique, almost always associated with the idea that giant corporations control the government, manipulate policies, and profit from conflicts. But what if we have been interpreting it too narrowly? What if, despite its flaws in public criticism, the American military-industrial complex is also a driver of technology, employment, and global stability? It may seem strange, almost contradictory, but the evidence paints a different picture. Imagine a small company in Los Angeles with 40 employees, experimental technology, and limited resources. 3 years later, it becomes a reference in the U.S. defense sector, employing hundreds of engineers, providing systems that later impact civilian life in areas ranging from drones to cybersecurity. This is not an isolated case. It happens frequently. The American military-industrial complex has evolved into a system that supports both large companies and startups, providing contracts, funding, and credibility that would be impossible in a purely commercial market. To understand this, we need to go back in time. The military-industrial complex as we know it did not exist before World War II. At that time, the United States did not maintain a permanent defense apparatus. Factories were mobilized only in times of war. Supply chains were improvised, and civilian production was the default. There was no constant war economy or formal partnership with private companies focused solely on defense. World War II changed everything. By 1941, the scale of production required permanent structures. The government created a coordinated system involving public sector, private industry, and research centers. Laboratories were built, procurement processes standardized, and the idea of a long-term strategic industrial partnership emerged. After the war, the apparatus was not dismantled. With the Cold War emerging, it became clear that maintaining continuous military capacity was essential both for national security and for technological leadership. The defense sector became permanent, combining public objectives with private growth potential, capable of developing technologies that the commercial sector alone could not handle. The economic effects of this system are significant. The defense sector generates trillions of dollars annually, supports millions of highly skilled jobs, and provides stability that other markets cannot match. Unlike commercial sectors, which suffer from economic cycles and demand fluctuations, defense spending is planned years in advance, allowing for investment in infrastructure, research, development, and human capital. Startups and small companies also benefit. Programs such as the Small Business Innovation Research, Defense Innovation Unit, and AppWorks create opportunities for smaller firms to test technologies, develop prototypes, and access contracts that would be impossible in the private market. Consider a company working on autonomous drones. Without defense contracts, it would be nearly impossible to test complex systems or expand operations. With government support, it gains the chance to grow, attract talent, develop solutions, and eventually turn those technologies into civilian applications. The benefits extend beyond direct economics. Many technologies developed for military use are later applied in civilian contexts. The internet, GPS, semiconductors, satellite communications, cybersecurity, advanced materials, medical systems, and artificial intelligence all have roots in defense research. The government can take risks that private companies cannot. Failure in a military project is acceptable if it leads to learning and technological advancement. In the private sector, failure can mean bankruptcy. This environment allows experimentation that later transforms civilian industries and society at large. Companies like Anduril, for example, started small, testing autonomous defense systems. Today, they lead the development of sensors, AI, and surveillance systems that also have civilian applications, such as border monitoring, disaster response, and infrastructure protection. Large companies also advance technologically because of this structure. Boeing, Lockheed Martin, Northrop Grumman, and Raytheon dominate, but competition between them encourages specialization, efficiency, and continuous technological development. Industry consolidation allows investment in complex research projects that individual companies could not finance alone. At the same time, oversight mechanisms provide some balance. Congressional committees, auditing agencies, investigative journalism, and public debate keep activities under scrutiny. Unlike authoritarian states, in the U.S., the military-industrial complex operates under public supervision. Politicians, bureaucrats, and companies risk exposure, budget cuts, or reputational damage. The system is not perfect and flaws exist, but these structures limit abuses while allowing growth, innovation, and technological development. Beyond economic and governmental aspects, there are effects on international stability. The American military-industrial complex is not only for war, it is a cornerstone of the strategy of peace through strength, often referred to as the Pax Americana. After World War II, the United States became a superpower, and the presence of superior military force had a deterrent effect. Trade routes were protected, international commerce thrived, and technological exchange accelerated. Countries understood that initiating conflicts with the US would be extremely costly. This stability allowed societies around the world to develop economically and technologically in ways that would be impossible in a multipolar conflict scenario. Another relevant point is knowledge transfer. Retired military officers, engineers, and scientists moved to the private sector or academia, bringing experience, methodologies, and organizational skills into civilian society. This has direct positive effects on the economy, education, and innovation outside the military sector. Dual-use technologies, developed for defense and later applied in civilian contexts, accelerate advances in energy, telecommunications, logistics, and medicine. GPS, initially military, is now essential for transportation, commerce, emergencies, and everyday use. The Internet, initially funded by DARPA, transformed global communication and commerce. Advanced materials and sensors improve medical equipment, environmental monitoring, and industrial production. These impacts rarely appear in public debate, yet they are widespread and deep. Small businesses take advantage of contracts to expand research and technological capacity. The sector provides financial stability that attracts investment and skilled professionals, allowing startups to grow and challenge larger companies. Long-term contracts and procurement planning offer predictability, encouraging investment in infrastructure, personnel, and experimentation. Despite criticism, such as contracts that allow cost increases or bureaucratic hurdles, these same contracts make it possible to execute complex, expensive projects that otherwise would be unfeasible. The result is a combination of research, experimentation, and industrial-scale production that is rare in purely commercial sectors. It creates a predictable market, encourages development of complex technologies, and produces products that later impact daily life. It also strengthens small businesses, supports entrepreneurship, and provides opportunities for investment in high-risk research. On the global stage, the effects multiply. Military presence, combined with technology exports, stabilizes regions, protects trade routes, and promotes international cooperation. Civil infrastructure benefits from technologies initially developed for defense. The domestic economy gains well-paid jobs, research and development, and technologies that spread across multiple sectors. The American military-industrial complex functions as a hybrid structure. It provides security, employment, technology, and international stability. Flaws exist, yet the positive impact is broad. Many everyday technologies have roots in this system. Startups thrive, engineers specialize, talent develops, and global stability persists. The complex is not limited to war. It creates conditions for economic, social, and technological progress. Criticism focuses on issues such as political influence, rising costs, and bureaucracy, yet a full analysis reveals significant positive effects. The internet, GPS, drones, cybersecurity, advanced materials, and modern medicine all originate from this ecosystem. Startups grow, professionals gain expertise, innovation spreads, and global stability persists. In summary, the American military-industrial complex is a structure that sustains security, employment, technology, and international stability. It is not perfect, it has flaws and controversies, but its contribution to technology, economy, and society is undeniable. When hearing military-industrial complex, it's important to remember that it also creates opportunities for research, company growth, technological development, and global cooperation. The duality is clear. A system designed for defense generates positive effects in civilian sectors, the economy, and global stability. The complex promotes progress and security while facing criticism. Recognizing its benefits without ignoring its problems allows a complete understanding of its role in modern society. In many ways, it is the foundation of American technological and economic leadership, providing jobs, research, development, and essential technologies.
The final question is not whether the system is perfect, but whether we can leverage its positive impacts while minimizing inefficiencies and abuses. The true value of the military-industrial complex lies in generating stability, growth, and innovation, benefiting Americans and the world.